بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will see logarithmic functions part 4, which is limits. What is the limit of ln x as x tends to 0 plus its negative infinity? And what is the limit of ln x as x tends to plus infinity, its plus infinity? Now, in the everyday language, we usually say ln 0 is negative infinity and ln plus infinity is plus infinity, and this happens only in case we are talking about limits. We know from before that ln 0 does not exist, but in case we are talking about the limits, we usually say ln 0 is negative infinity and ln plus infinity is plus infinity. And this should be memorized by heart. Now let's remember together how do we calculate limits. In fact, the first step in calculating limits is substitution, and this is what we saw before. And in case we use substitution, we might get the answer or we might get an indeterminate form. Now, in case we get infinity over infinity or 0 over 0 as an indeterminate form, these two cases are going to be solved using L'Hopital's rule. And in case we get plus infinity minus infinity, we're going to take a common factor. And in case we get 0 times infinity, we're going to use reciprocal. And let's see what do we mean by this chart. Now remember, the first step in calculating a limit is substitution. You have to remember that ln 1 is 0 and ln e is 1. You have to also remember that the limit of ln x as x tends to 0 plus is negative infinity, and the limit of ln x as x tends to plus infinity is plus infinity. You have also to remember that k over infinity tends to 0 when k is never infinity, and k over 0 tends to infinity when k is never 0. The indeterminate forms are infinity over infinity, 0 over 0, plus infinity minus infinity, and 0 times infinity. Infinity over 0, we deal with them using Hopital's rule. Plus infinity minus infinity, we take a common factor, and 0 times infinity, we apply the reciprocal method. And if f of x is ln u of x, then f prime of x is u prime of x over u of x. Let's see example 1. Find each of the following limits. The limit of ln x as x tends to 1. Well, the first step in calculating a limit is substitution, and by substitution, the limit of ln x as x tends to 1 is ln 1, and ln 1 is 0. The second limit, also by substitution, we see that the limit of ln x over x as x tends to e by substitution is ln e over e, and ln e is 1, and the final answer is 1 over e. What is this limit as x tends to 0 plus? Also by substitution. And in fact here by substitution we get 0 minus infinity, which is negative infinity. Remember, the limit of ln x as x tends to 0 plus is negative infinity. Now this limit, also by substitution, we get plus infinity because we have in this case plus infinity plus infinity. Remember also, this was memorized by heart, that the limit of ln x as x tends to plus infinity is plus infinity. Now this limit, by substitution we get ln e over e minus e, which is 1 over 0 plus, which is plus infinity. Now this limit, also by substitution, we get negative infinity over 0 plus, which is negative infinity. Fortunately, this also could be memorized by heart. The limit of ln x over x as x tends to 0 plus is automatically negative infinity. Now this limit, by substitution we get plus infinity over plus infinity, and this is an indeterminate form that is usually solved by using L'Hopital's rule. Remember, we derive the numerator alone and the denominator alone. We get the limit of 1 over x over 1 because the derivative of ln x is 1 over x and the derivative of x is 1. And after we apply Hopital's rule, we reapply substitution, we get 1 over infinity, which is 0, and 0 over 1 is 0. Also, fortunately, here we can memorize this one by heart. And by now, we've memorized 4 limits by heart. Now, this limit, as x tends to e, well, by substitution, we get 1 minus ln e, which is 1 minus 1, which is 0, and e minus e, which is also 0. And 0 over 0 is an indeterminate form that is usually solved by Hopital's rule. So, we derive the numerator alone and the denominator alone. We get minus 1 over x over 1, because the derivative of 1 minus ln x is minus 1 over x, and the derivative of x is 1. And after we resubstitute, when x is e, we get minus 1 over e over 1, which is minus 1 over e. Now, this limit, we try to divide it into 2 parts, as you see. The limit of the first plus the limit of the second. Now, the limit of the first could be solved using L'Hopital's rule because we have plus infinity over plus infinity, and the derivative of x is 1, and the derivative of x plus 1 is also 1, whereas the limit of the second part is 0. This was memorized by heart from part G, and the final answer is 1 plus 0, which is 1. And now let's continue with this limit. If we substitute, we get plus infinity minus infinity. And in case we have plus infinity minus infinity, we take a common factor. And let's see what do we mean by this common factor. We either take x or ln x in common. If we take x in common, from here we get 2, from here we get ln x over x, and from here we get 1 over x. And after taking x in common, the limit of ln x over x as x tends to plus infinity becomes 0. This was memorized from before. 2, this is 2, and this is 1 over x. And then if we apply plus infinity here, 1 over infinity is 0. And this becomes a plus infinity. Now let's see this limit. Also by substitution, we get plus infinity minus infinity, because the limit of ln x as x tends to plus infinity is plus infinity, and the limit of minus ln x as x tends to plus infinity is negative infinity. So again, plus infinity minus infinity, we take a common factor, and here the common factor would be ln x, and if we take ln x in common, we get 2 ln x minus 1, and if we substitute, the first part leads to plus infinity, and the second part also leads to plus infinity, and the final answer would be plus infinity, because we are multiplying 2 plus infinities by one another. Now, part L, the limit of x ln x as x tends to 0 plus. Well, by substitution, it leads to 0 times the negative infinity, because the limit of ln x as x tends to 0 plus is negative infinity. Now, 0 times infinity, we apply the reciprocal method. Let's see what do we mean by the reciprocal method. Remember here, please, if a and b are two non-zero real numbers, a times b could be written as b over 1 over a. And if we apply this procedure here, we can say that x ln x could be written as ln x over 1 over x. And by now, if we substitute 0 plus, we get ln 0 plus, which is negative infinity, and 1 over 0 plus, which is positive infinity. So we get infinity over infinity, and in case of infinity over infinity, we apply Hopital's rule. And Applying Hopital's rule, we derive the numerator alone and the denominator alone, and the derivative of ln x is 1 over x, and the derivative of 1 over x is minus 1 over x squared. And after few simplifications, if we simplify this mixed fraction, we get minus x squared over x, which is minus x, and the limit of minus x as x tends to 0 plus is 0. And this could be memorized by heart and applied directly. The last limit, which is part M, find the limit of x ln x plus 3x as x tends to 0 plus. So here, the limit of x ln x as x tends to 0 plus is 0, and this is memorized by heart. And the limit of 3x as x tends to 0 plus is 0, and the final answer is 0. So far, dear students, you have to remember many things, and the list is becoming longer and longer. Remember, ln 1 is 0, ln e is 1. The limit of ln x as x tends to 0 plus is negative infinity. The limit of ln x as x tends to plus infinity is plus infinity. The limit of ln x over x as x tends to 0 plus is negative infinity. And the limit of ln x over x as x tends to plus infinity is 0. And the limit of x ln x as x tends to 0 plus is 0. These 5 limits could be memorized by heart and applied directly without any proof. But remember, other limits should be proved. We have indeterminate forms, infinity over infinity, 0 over 0, we use Hopital's rule, plus infinity minus infinity, we take a common factor, and 0 times infinity, we apply the reciprocal method. Now find each of the following limits. Try to do it alone. Well, if we substitute 0 plus, we get ln 0 plus, which is negative infinity, squared, it's positive infinity, plus 0, which is positive infinity. Try to do the second limit and compare your answer. Okay, when x tends to plus infinity, we get ln plus infinity is plus infinity over plus infinity. So we can apply Hopital's rule. We derive the numerator alone, the denominator alone. The derivative of the denominator is 1. The derivative of the numerator is u prime over u, which is 1 over x plus 1, which is 1 over infinity, which is 0. Well, this limit, try to do it alone. Take your time. If we substitute, we get plus infinity minus infinity plus 2, so it leads to plus infinity minus infinity, and in this case we take a common factor. Here we take ln x in common, and if we take ln x in common, we get ln x minus 1 plus 2 over ln x. But remember, when x tends to plus infinity, ln plus infinity is plus infinity, and number over infinity is 0. So this quantity tends to 0, and we get plus infinity times plus infinity, which is plus infinity. Now this limit, try also to do it. Let's see. If we substitute, we get 0 times negative infinity. And the easiest way here is to expand to get x ln x, because we've memorized before the limit of x ln x as x tends to 0 plus, which is 0. So this is 0, this is 0, and this is 0. So the answer is 0.